So as Gary mentioned, I was very fortunate back to get a job up at Lick Observatory. It's actually my fun job. Give you a little background on myself. I'm a senior process or manufacturing engineer currently at what was called Space Systems Loral, now called Maxar in Palo Alto, California. Been doing that while working at Maxar for about 15 years now, and it basically involves just setting up soldering machines, wire bonders, epoxy attached machines, things like that. Not always too interesting, but the job up at Lick Observatory has been a lot of fun for me. Learned a lot of things up there. So like a lot of you, got my start in astronomy career at a pretty young age, actually. I was in Hawaii in 1965, and my father dragged us out of bed early in the morning to go out and take a look at Comet Kayaseki, which was an amazing thing. And if anyone here had seen that, it was very impressive, but only for a few days. It didn't stick around very long. And so that was sort of my start into astronomy. And about 1970, same thing happened. Comet Bennett, which was called the Easter Comet, came around and was almost as bright as a searchlight in the sky. And that really got my interest. So I went around and started, got a small 60 millimeter telescope, like a lot of you probably did. That wasn't big enough. So I got an 8-inch telescope in high school, built my own mount on the high school lathe, and kept going from there. So wanting, like a lot of astronomers, we get aperture fever. We want bigger and better telescopes. So up at Foothill College, right after high school, I started working up there with the instructors, working the 16-inch telescope, which is a Newtonian up there, and found out that the club had a Oak Ridge Observatory with a 16-inch or actually at the time was a 12-inch cave reflector, Newtonian, beautiful telescope, but it needed a lot of rebuilding, and the ground up there needed quite a bit of attention. So right from the get-go, and I joined the PAS in 1978, I've been going pretty strong for the club ever since. So about 2015, I saw this ad in Facebook on the Lick Observatory page, said we have an opening for a public programs telescope operator. Say, okay, well, what's a public programs telescope operator? Well, it's not too different than what we do at Foothill when we open to the public. I want to be knowledgeable about the sky, knowledgeable about using telescopes, of course. And, I had a little time. I figured, okay, if it's a part-time thing just in the summer, why not give it a try? So I applied. And being a public program telescope operator is quite different from the regular volunteer work up at Lick Observatory. And I'll tell you why in a few moments. But at the moment, there's about 8 public program telescope operators at Lick. And we take turns. We get a schedule, and we basically apply for the type of job that we want to do for certain evenings. And some of us can't do weeknights, and the rest of us, most of us can do weekends, of course. And that kind of gets us going. So a public program telescope operator, we have essentially 2 functions. Number one is to run the telescopes up at Lick, and that includes the Anna Nickel telescope, a 40-inch telescope that's in the North Dome on the main building. This telescope is still used constantly for scientific work. It's overbooked constantly, but we still, on public nights, mostly what's called the summer series of events at Lick Observatory, we actually do open it, put an eyepiece on it, take the spectrographs off, take the photometers off, and we let people look through it. And it's a magnificent telescope, a really, really pleasure to use this thing. The other telescope we use for public programs is the great James Lick 36-inch refractor. Now, the weird part about this is we have lots of volunteers and staff at Lick Observatory that bring their own telescopes up for our events in the summer. They have some magnificent telescopes, big refractors, big reflectors. And so why do they need a public program telescope operator or a staff member to run these telescopes? Well, problem happened about, I believe it was about 2012 or so. The floor of the observatory raises and lowers to get people up near the eyepiece. And they had a little damage, which you can see here down under the floor. these gears and bevel and rack and pinion you see here is basically a leveling system for the 60-foot diameter, 26-ton floor. So this damage doesn't have anything to do with the floor ever falling. The floor really can't do that. It's counterweighted, and it also has hydraulic rams underneath it. But the UC engineer, when these teeth broke, he was worried that if the thing is up at a 10 feet, 16 feet above the bottom of the floor there, that it actually could break and cause the floor to tilt a little bit. And he was worried that might throw people. And so right now, with the public on the floor, we cannot operate it any longer. Now the floor is operational. I've been on it. It does go up and down, but and that's why we have to be a staff member. We have to be insured to be able to use that floor. But since we can't use that for public programs, we're left with no other choice than to climb the pier of the telescope, go up to the right at the base of the equatorial mount there, and you can see those little ship's wheels around the top. We have to go up there and move the telescope in right ascension and declination with those ship's wheels. So we are staff members because we have to be trained in repelling gear. We have to be insured, as I mentioned, and that's basically the reason that we're called a public program telescope operator, not just a normal Lick volunteer up there. I would do this job, by the way, if I was just a volunteer. Be more than happy to do it. So part of our job on the 36-inch at least is to climb the back of the spiral staircase 27 feet above the floor to operate the telescope. And this thing it's an impressive telescope, as you know. I won't get into all the details of the scope itself because that's really not a really behind the scenes thing, because anyone that comes up for our public programs, we always use the 36-inch. We don't use the 40-inch on everything. And we do use the 36-inch if it's clear, of course, and the wind or weather's not causing a problem. But the telescope became operational in 1888, was the largest refractor in the world at the time. It's 57 feet long, 36-inch aperture, and there's only one refractor in the world that's larger than this, the 40-inch at Yerkes in Chicago. So, getting up there, that gives a bit of an image scale of how big the telescope is. And again, it's a magnificent thing. One thing we really enjoy doing is being staff members up there. We get an opportunity to actually sit back and take some photos of the telescopes inside and out and do time-lapse photography and other things like that. And I'll get into that in more detail a little bit later. So here's a view if you want to see what it looks like from being up, looking down at the floor of from up there where we operate the telescope. It's a long way down. Certainly wouldn't want to fall all the way down there to the floor. That floor, by the way, is original. It's a magnificent wooden, piece of art, really. A lot of people look at those bands and it looks like Saturn's rings almost, but not sure if that was on purpose or not. So if you ever have been to Lick Observatory, there are quite a few public programs. The two main ones where we get a lot of people up there, about almost 200 people at a time, to look through an object in the 36-inch refractor and another object in the 40-inch refractor. We call them Evening with the Stars, which is on Friday night. And we have something called the Music of the Spheres, which is essentially the same program, but it includes a concert. And we've had concerts up there. We've had Celtic music. We've had, chamber music. We even have had a Beatles tribute band that's called the White Album Ensemble. Really good group up there, and hopefully they'll get them booked again later this year. A couple things people don't really know about. We do have what's called public evening tours. Now, these are kind of scheduled tours. It includes a walking tour of the mountain to a lot of the places I'm actually going to show you tonight, but primarily only the Shane 3-meter or the 120-inch reflector. These public evening tours, we do have some booked already this year, and they're going forward even with the COVID restrictions. There's a little selfie mirror I wanted to point out to everyone right near the 36-inch dome, right at the turn at the bottom, just before you get up to the main building. So if you ever get a chance, you take a shot there. Another event we have they're called photography nights. Photography nights we've set up. We get about roughly 60 people up there, and this is a night where you're actually not going to look through the telescope, and you cannot put your camera on the telescope. We simply set the telescope up in nice positions. We turn the white lights on for a while. We turn the red lights on for a while. We set up so that you can look at the through the dome slit outside and see the telescope sticking up and pointing at the sky. And there are other places around the mountain we allow the photographers to go for the rest of the night. And it's actually a lot of fun. You can get some really cool shots like this with the dome spinning. And we had a foggy night one night where we couldn't open the dome actually, but it looks like a little searchlight on the coast there looking out. So we also do private tours, and these are actually pretty interesting because you can actually rent out the 36-inch for till midnight. I don't know the cost. The last I remember a couple of years ago, and please don't quote me on this, but the cost for the evening was about $1,700 or so, and there is an insurance rider and a couple of other things you have to do. But we get these private tours booked quite often. It's a lot of fun. They do weddings, kind of the same thing. It's a private tour. There's been a few weddings up there that I've attended. It's a blast. And I even had one time a couple come up. This guy and this girl, his fiance, wasn't fiance at the time. They came up and he proposed right in front of all of us. I was crying. It was pretty amazing. Really neat to see. So it was a fun night, but just the two of them, we were going through so many objects that evening, like I think over 30, and I was climbing that stairway up to about halfway through the night until I finally decided to just stay up there and operate the telescope without coming down every time. So the summer series, the good news is it's basically back on. Tickets are going to go on sale April 13th this year. And I want to point out one really important thing for everyone that is actually a pretty inexpensive way to get the tickets and get priority on the tickets is if you join the Friends of Lick Observatory. It's about the cheapest is an individual, about $50 a year. And that gets you a 1 week jump on the public ticket sales. So it's well worth it. I highly recommend doing that. And we'll go from there. So the first telescope I'm going to show you this evening, and the first objects really, is that we don't hardly ever get a public tour to. These are done on special tours, and they're done by like the principal investigator of the telescope. It's called the CATE telescope, and that stands for Katzmann Automatic Imaging Telescope. It's a 30-inch aperture, fully robotic telescope that's primary duty is to take pictures of galaxies every night, can do about 1,000 galaxies a night, and it will sit there and look at those galaxies looking for supernova. So the Katzmann is the furthest east on the mountain. It's at the top of the mountain, the highest observatory dome on the mountain. And but it's pretty small there. It's nestled between a couple of water tanks up there. Now I met one of the designers, Russ Jeanette. He's originally from his own private observatory, Fairborn Observatory, and he was very instrumental in the late 1970s of working on robotics, and he actually used Tandy computers to run stepper motors to where he could automate the motion of telescopes, and he was one of the first guys to do it. And we were lucky enough that he came up and gave us a talk and gave us a tour of the Kate one day. Pretty amazing telescope. It is fairly small, with only 30 inches in diameter. But the principal investigator, Alex Filipenko, has made history with this telescope. And I won't go into all the details, but looking at supernova remnants, or supernova, excuse me, in the sky and gauging the distance to galaxies, it's one of the key sets of data that we're using to notice that the universe is not slowing down. It's not steady state. It's actually accelerating in its expansion rate. And this Kate telescope was one of the the key data gatherers for that information. Here's a picture of Alex with the Kate, and a really happy picture of Alex with the Kate. He's a neat guy. If you've ever seen one of his talks, he is absolutely an amazing speaker. Really nice guy. I love working with him. So the camera that's on this, by the way, pretty simple. It's a NextBig 402 ME camera. So what this thing does, as I mentioned, it takes 30-second exposures. It could reach to 19.5 magnitude with every exposure. So it can do about 70 galaxies an hour, or roughly in the winter months, it can do about 1,000 galaxies per night. So it takes a picture, compares it to images that were taken previously, and instantly compares those. If there's a new star in the field, it may be a supernova. They do follow-up studies afterwards with the Shane telescope at Lick also, and other places around the world. Because another point of light could be an asteroid or something else, or even just a defect in the image. But yeah, pretty amazing telescope. But the Kate wasn't the only telescope in that dome. Initially, there was a Bowler and Chevins 24-inch telescope that got installed in the 1960s. Here you can see the mount being put into the dome. So this is the dome that the Kate is in present day. That particular telescope was used for quite a long time, about 15 years, and it did photometry and a little small scale spectroscopy, if I have my facts correct on that. So that Kate telescope, again, not on a regular tour at all. So hope I give you a little bit of insight of at least what it looks like and what it does. So the next telescope on our list is what's called the Carnegie Double Astrograph. It's a fully decommissioned telescope. It's no longer used, but it is a 20-inch aperture, but there's two of them, astrographs side by side. And they actually had the blue lens, which was first used for blue sensitive photographic plates, began operation in 1947, and it went to about 1954 when they did the first series of epoch plates. Now, this telescope was used for basically one purpose. It was to take picture of the whole sky on these plates, about 1,000 exposures to reach the entire sky. And then 50 years later, they were going to take pictures again and see if the stars move. They're looking at basically what's called proper motion, or just the XY motion of the stars on the plane of the sky. But when they added the second lens, that one was corrected for yellow light. So with blue light on one plate and yellow light on the other plate, you were able to get a little bit of magnitude difference, and therefore color, a little bit of an idea of what spectral type the stars were. They did actually have grading, diffraction gratings on these to actually take spectra as well, but those weren't used very often. The yellow lens became operational in 1962. So this telescope I'll show you a location where it is on the mountain. It's right next to the Shane Dome, which is the large dome on the right there. And the double astrograph is right next to it. The double astrograph's an older dome than the Shane Dome. Shane Dome's a little newer. And here's a shot of the double astrograph from the Shane catwalk in about 1959 when the Shane opened. It's a construction shot, shows the north pier of the thing, and it's all cement walls. So the 4-element 20-inch Ross lens is a wonderful lens, very flat field, f7 focal ratio. And it was designed by Frank Ross, a brilliant optician. And he did building two of those lenses took a major part of his work for many years. So here's the double astrograph today. And I think that's about a 10-inch finder on the side. I wish I had that finder all to myself in my backyard. It would be great. So this thing, as I mentioned, about 1,000 plates to do the entire sky. And over 3,600 plates were taken and eventually actually digitally scanned in Arizona. And here's a shot through the plate holder up toward the objective with the light baffles inside. So the mounting of the telescope was made by Warner and Swassey. They are the same people that made the mount for the 36-inch refractor and the 40-inch refractor at Yerkes. So here's the back end of the telescope. You can see the finder there on the left. You can see the two plate holders. Now these were essentially 17-inch by 17-inch glass plates, a little less than 2/10 of an inch thick. Probably cost a lot of money for those things. And when I got up there in 2015, there actually were a couple of plate boxes inside the dome, but they've since been removed. Wish I would have grabbed one of those. So as a serendipitous set of discoveries taken with the Crossley, or excuse me, the double astrograph, they actually looked at these plates, and there's a whole bunch of galaxies on this. They hired grad students to start counting galaxies and where they were on the plane of the sky, and they started graphing these. And I remember seeing this image come out in the early 1970s in Astronomy magazine, and it shows the structure of essentially our universe, or at least more of the local portion of the galaxies, and the filaments and the clusters and everything. Pretty amazing. And so this was quite a finding for a telescope that was not designed to even begin looking for something like that. So the double astrograph, as I mentioned, is really not any longer used, but they did find a use for the dome. They painted it recently and received a brand new coat of paint, because they're going to use the dome itself for a new experiment called PanoSETI. And what PanoSETI, I mean, the SETI portion of it, as you can imagine, is search for extraterrestrial intelligence. These are Fresnel lenses that are on inside the dome. And it's going to eventually, they're just testing the system right now. These Fresnel lenses actually feed a detector. They're looking for essentially laser light from the sky, because laser light does not happen naturally. It only can be made by intelligent beings. And so these two lenses look at the sky, and the dome doesn't rotate. It's not on a mount. It just looks at at the same azimuth and altitude. And as the sky rotates through, it's sitting there looking for laser light. And eventually, these will go into a big array, as you see there on the left-hand side, looking at the entire sky. Pretty amazing feat of engineering there. That should be a really interesting project. I don't believe the array itself is going to be on Lick Observatory. I think that's going somewhere else. So one little side note, this isn't really related to a behind the scenes thing, but one day when I was laying home sick, I was watching the Turner Classic Movies, and I came along this movie called The Gift of Love. It's kind of a little hokey movie. It was made in 1958, but it stars Lauren Bacall and Robert Stack, and they're in the movie. Robert Stack is an astronomer in the movie, or he's an astrophysicist actually. But there are a lot of scenes actually that were taken up at Lick. Now I don't believe the actors and actresses were actually on the mountain. They used doubles because of all the pictures on the mountain. They're pretty distant shots, so pretty sure it wasn't the actors themselves. But here's Lauren Bacall's double going into what looks like a door to the observatory, and that's actually just a little utility closet that has generator in there and everything. So it's kind of interesting little side note of a double astrograph history there. Okay, our next telescope is a really interesting one. Probably never seen anything quite like this. This is called the 22-inch Tachman Cassegrain. It was built in the 1930s by an amateur, George Tachman in Berkeley, California. And a 22-inch mirror at the time, I mean, that was the largest amateur built reflecting telescope in the world, if not, in the United States, if not the world, because a 22-inch mirror is getting so big that you can't push that much glass around by hand. I mean, a 10 or 12-inch mirror grinding and polishing one's about all that most people can handle. 22-inch, you had to make a grinding machine to do this telescope. And the location of the Tachman, it's kind of in an interesting spot. This is a shot from the Lick Ham Cam, and it's right there. It's just a little dome down on the bottom. Here's a shot, a very, very old shot of that. And I wanted to show you this because the observatory is actually built on an old water tank. This is the water tank. It's called that's built on what's called Huygens Peak at Lick Observatory, and the water tank was used for the hydraulics that used to operate the floor and the dome rotation of the 36-inch refractor. It was no longer needed, so they ended up building the Tachman. They filled that tank up and built it right there. Since we're on this photo, and this is something, again, that's not going to be a tour type thing, but this is a kind of a neat photo because it does point out a couple of interesting places on the mountain. This is a telescope called the Old Crocker Dome. It's since been removed. It actually has been moved to another location. And one thing that we have in the main building, someone found a photo of a dome that's very near the Crossley Dome, really small dome. Wasn't there very long, apparently, but no one knows what was actually in that yet. We've been trying to find that out. We'll probably have to go to the archives and start looking through letters and other things to figure out what that is. Okay, so here's a modern view of the Tachman. You can see, and this is during just after a total lunar eclipse just last year. It's kind of a neat shot, but the Tachman's sitting there up on top of that water tower. So every now and then the Tachman does get used by, it's primarily for staff members only. It is never used for the public. However, every now and then someone does get some special permission to get trained and use the telescope. And this photo here is of a gentleman named Russell Crotty. He's an artist, and he actually was using the Tachman to take look through the telescope and take images and do some artwork, which I won't show here, but he's a fantastic artist, really neat guy. Some of the equipment in the Tachman, does have synchronous motors. So it does need a frequency generator to turn the telescope at the right sidereal rate. And neat stuff. That's like 1950s era electronics there. So George Tachman wrote an article about this telescope back in 1931 or 32 issue of Popular Science. And it details the telescope quite a bit. You could see there, he actually had the telescope in Berkeley at first set up in a 2-story observatory dome. Pretty amazing at the time. Again, that early in the century. It's a pretty good shot of the tube, that spiral, riveted structure. Pretty unique. So Lick Observatory purchased the Tachman in 1950. It was moved to that site I showed you. And it was used primarily by Cron and other famous astronomers for some early photoelectric work, photomultiplier tubes. I don't know the details of all the type of research that was done with the Tachman. It was used primarily, from what I've been told, as the photoelectric studies. But the Tachman is available to staff members. I've had a few friends go up there with me and be able to look through the telescope. So that is always a possibility. But again, this is never seen on public tours. We've never opened that dome. There really is no funding to operate the telescope. It's volunteer work pretty much that keeps it in shape, painting it and everything. It's all donated work. So, but we still keep it operational. There's a beautiful sunset shot from the Tachman porch there, looking back toward the 36-inch refractor. All right, so our next scope that we, again, almost never see is the Crossley 36-inch telescope. Now, the Crossley is a very famous telescope. I'm not going to get into all the details, but it's I call it the grandfather of all modern reflectors because it was the first large telescope made with a glass mirror that was silvered chemically rather than being speculum metal, big, heavy copper tin mirror like Lord Ross's telescope in Ireland that had to constantly be repolished because the speculum metal would tarnish so quickly. So this telescope is very, very famous, did a lot of great work. And but inside this shot here, there's a beautiful marble inscription when Edward Crossley donated this to Lick Observatory in 1895. He was they made it very special. The Crossley, when it was received, was pretty rickety. Wasn't really that good a telescope. In fact, one of the astronomers, Hussey of Lick Observatory, called it a pile of junk. And you can see there's actually a wedge on the bottom of there holding the mount, which had to be made because the difference of the latitude of Lick Observatory versus Halifax, England. So the telescope was pretty rickety. It was completely rebuilt in the early 1900s, about 1910 or so. And the only thing that survived of it was the mirrors. The rest of it was completely scrapped, and an entire new mounting was built, which did work very well. The problem with this thing, unfortunately, was it's a Newtonian focus. It's not a Cassegrain, so the eyepiece is all the way at the top, and that catwalk is attached to the dome, and you had to rotate and walk around that catwalk to get to your plate holders and your spectroscopes and other things. And that was a pretty precarious. That's a long fall down there. Should you slip. There are a couple of stories of a couple of incidences happening there. I won't get into those details. Otherwise, we'll be here all night. All right. This thing was last used in about 2010. It was used, you guys know what gamma ray bursts are. Satellites detect gamma rays. They don't reach all the way to the ground generally. And this thing was used quite a bit to, once the satellite detected a gamma ray burst, calculate the position, they'd get on a hotline phone to an observer that was in the Crossley with cameras and detectors that were trying to get the afterglow of a gamma ray burst. Don't really recall if they were successful on that, but one of our public program telescope operators, Bob, was one of the last people to ever use this telescope. All right, now we get to the big telescope, the Shane. Now the Shane is on all of our tours. We do go into the dome quite often to see the Shane. It's the largest telescope on the mountain. And when it first became operational in 1958, 1959, it was the second largest telescope on the planet. It was a big telescope just underneath the 200-inch at Mount Palomar. So this became operational again about 1958 or so. It's a beautiful telescope. The dome is almost the same size as the 200-inch at Palomar because it's actually an f5 focal ratio instead of f3.3 like the 200 inches. So the dome is rather large. So there is a catwalk around the outside of the dome, which on some occasions, not every single time, we do get a chance to take our tour group out on the catwalk and let them walk around completely around the dome. So here's one little object that we don't see any longer. The 120-inch did have what's called the prime focus cage. The light from the primary mirror came straight up into this cage, and you would actually put your plate holders and take your pictures right from this cage. The 200-inch had a very similar cage, but since the 120-inch is so much smaller, this cage was actually very, very small, and it was even oval in shape in cross section to try to not block as much light heading to the primary mirror. So our staff astronomer, Dr. Eleanor Gates, my boss up at Lick, she was the last one to use that prime focus cage in about, I believe she said 1997, 1998 timeframe. So it's now down way under the floor, about the second level below the telescope, the Shane telescope in storage down underneath the floor. So I get, and this we normally don't see on a tour either. So I was able to get a shot of that one day when I was walking through the Shane. So the Shane's a wonderful telescope. It's really, really neat to watch use, but obviously as I don't get to use this telescope. I wish I could. Some of the electronics, again from the 1950s, clearly visible still on the observing floor, and they actually still are used to this day to operate the telescope. Now the telescope is, of course, computer controlled completely, and it can be run remotely by people pretty much around the world that get
cool.
their time in there. So here's a shot that that all but a staff member really cannot take. I had to get special permission to go into the dome when it was open, when it was doing some imaging. We obviously had a little work being done inside because the red light is on. Normally that would be completely dark in there. And so they're kind of proud of this shot. It's kind of a neat shot that, again, you pretty much can't take a shot like this unless you're a staff member. All right, so about every 5 years or so, the main mirror of the Shane needs to come out and get re-illuminized. And that's a quite laborious process. They normally do it at a time of year when the weather's bad, like around February timeframe. And they take that thing out from the tube, they get it on a carrier there. They strip the aluminum coating off of that thing, and then it gets actually, I don't want to use the term dropped. I like to use the term lowered underneath the floor into a very large vacuum chamber. That's big red chamber that you see is what we opens up and we re-illuminize the mirror. And this chamber was actually a very fortuitous thing that Lick Observatory got back in the early days. It's actually an old cyclotron chamber from Lawrence Berkeley or Lawrence Livermore Labs. Can't remember which one. It was purchased for about $50,000, which was really cheap at the time because that's probably a $1 million piece of hardware. And when the mirror gets put into it, it takes about 2 days for them to pump this thing down to about 10 to the -5 torr or so. Big cryo pumps you see on the side there. It takes quite a long time to get the pressure down where they need it. And then they flash some very pure aluminum, almost look like paper clips from the other end there. In the front, you could kind of see that area where all the electrodes are hanging. And then they flash that aluminum in a certain sequence so that it vaporizes onto the mirror very, very effectively. Again, I won't go into a lot of details, but I will point out that on our Lick Observatory ham cam page, a lot of you are familiar with this. There's quite a few cameras at Lick taking pictures. There's all sky cameras. And down at the bottom of the page, there's a really neat little spot down here where the illuminizing process, time-lapse photos taken primarily by Dr. Gates of that process. So you see days worth of work being done on that mirror. And it's really neat to see. So I highly encourage you all to take a look at that link and spend some time. And it's a marvelous thing to see that work that's done on that mirror. All right. So just like the gift of love on the double astrograph, there's another movie, the only other one that I know of that was made at Lick Observatory. And this one was actually filmed with the cast up there at Lick Observatory, called Once Upon a Spy. It's obviously a spy spoof about 007. It starred Ted Danson, Mary Louise Weller, and one of my favorite actors was Christopher Lee. I love Christopher Lee. He's been a good bad guy for many, many years. And he even had a wheelchair that fired missiles out of it. It was really cool. And like I said, one of my favorite bad guys, Man with the Golden Gun, Saruman and Fellowship of the Rings, and Star Wars is Count Dooku. Neat guy. Passed away just, I believe it was last year or the year before, unfortunately, but a really amazing career. So in this movie, we get a laser blast coming out of the Shane, and that actually isn't too far off of what happened when they were shooting this at the Apollo 11 retroreflector on the moon. I'll get to that in a moment. But there's kind of shots of the real laser guide star laser shooting out of the Shane Dome from the movie again, and the laser guide star adaptive optics shooting out of the Shane Dome. Neat shot. So the 120-inch was used to bounce the first laser shots off the moon that Neil Armstrong and Buzz Aldrin put on the moon. They were actually shooting that very soon after they touched down. After they put this instrument out on the moon, they were very quickly shooting at it. But the Apollo spacecraft landed a little downrange and was they didn't know the position exactly right, so they didn't get bounces while they were actually on the moon. The laser that was used is about a 1 gigawatt ruby laser, very powerful laser. And just recently, 2019, they actually put a IEEE milestone plaque in the lobby of the Shane Dome, which you can see if you're on your own walking tour of the mountain, which people do. All right, so we're going to get a little bit of info on the 36-inch refractor. And again, this isn't really technically a behind the scenes thing because we all get on all the tours get to use the refractor. But there's a few things that are kind of neat that I've only seen once or twice in my 6-year career up there. On that one cloudy night, we actually were able to lower the objective lens end of the telescope down low enough where we could actually take a look at the glass and the famous 36-inch lens. made by Alvin Clark and Sons, of course. It's a beautiful piece of art, really, and scientific ability. The green band you see in there is the separator between the two lenses. It's about 6.5 inches wide, so there is a big air gap separation in the lens. And this shot's from a very old shot. Looks basically the same. A lot of people do not know there's a third lens to this telescope. It goes on the front of the other two. It's 33 inches in diameter, and it is a corrector and field flattener lens. It removes a lot of the chromatic aberration that the doublet has, and it also flattens the field quite a bit. This was very expensive at the time, about $50,000 in 1888, and that's as opposed to $700,000 for the entire observatory. So it was an expensive piece of glass. But this thing was used for primary lunar photography on a large plate, about 10 inches square, and thus that needed to be a flat field. But it shortened the focal length by about 10 feet. So there's a little port in the side of the telescope where the plate holder went, and the focusing mechanism and everything else had to be piped out with optics out to the side so that it could be focused at that particular spot. This is just in a old office that hardly anybody again gets to see. It's actually a safe, a steel safe that housed a lot of the optics in case there was a fire on the mountain. The lenses and the eyepieces and everything would be put into this safe and hopefully kept safe. A lot of people have been down underneath the floor of the observatory to see James Lick's tomb. And the only reason I point this out is it's not always seen on our tours. Sometimes we get a chance to get people down there and other times we don't. So if you've never seen James Lick's tomb underneath the pier of the 36-inch refractor and you're up there on a tour with us, please ask and we'll do the best we can. Part of being a staff member also, we get to see some of the really beautiful, fantastic instruments that were used on the 36-inch refractor and other telescopes, the Crossley, etc. This filler micrometer, amazing piece of work. Here's a period photo of it. Some of these things are just beautiful. I mean, those the dials on this micrometer are actually ivory, pretty amazing. And here's a quartz prism double micrometer I actually got to hold once. This was a volunteer appreciation night where one of the astronomers, Tony Mish from Lick Observatory, brought these instruments out and allowed us to take a look at them and look at them really closely. So one of the really cool perks about being a PPTO or a staff member at Lick Observatory is on rare occasions, doesn't happen every day, we actually get to throw our cameras on the refractor and the 40-inch nickel reflector. Now this shot is just a straight shot. This was not processed. It's not stacked in any way of Jupiter, and you can see the red spot. And one day I'd love to take a series of shots and stack these and see what we can do with it. So Eskimo Nebula shot. Again, there's no stacking, no processing. This was with the refractor also. You can see the chromatic aberration around the bright star there. This shot is actually stacked about eight stacks and processed a little bit, but with the 40-inch reflector and a nickel telescope. The moon, crater Tycho, single shot, no processing except just contrast. That was it. For the first time in 6 years, we got an opportunity to actually look at the Orion Nebula through the 36-inch refractor. And this is a 10-second exposure, single frame of the nebula. This is a little bit of a stacked, Brian Day, my NASA friend, took about eight exposures, stacked these and did some processing. You see quite a bit of detail in the nebula there, plus the trapezium. It's really amazing. Looking through the refractor, you know, you of course want to see the trapezium and the extra stars because a couple of these stars were discovered with the refractor. The G star was actually discovered before the 36-inch was operational, but the H and I stars were, I believe, discovered at Lick Observatory. This is a logbook from the director at the time, first director of Lick Observatory, Holden. And he does point out a little star there called Clark star. That's the G star in the previous diagram. This is from 1888. And a few more shots. This was with the 40-inch nickel telescope. It's M2, the Saturn Nebula, and the Ghost of Jupiter planetary nebula. So if you've been to Lick before, or even if you haven't, one very cool thing, which happens pretty rarely, I've only seen it about 4 times since I've worked up there for 6 years, but the staff that lives up there see it quite often, is Half Dome, all the way across the Central Valley of California, 120 miles away. And if you're on the mountain, there's only one good place to see it from near the main building. Is there's a flagpole to the north side of the building near the 36-inch refractor, and there's a set of binoculars that are there for viewing as well. And we actually have a piece of tape, piece of blue tape lined up with that binocular to look out over the valley to where you can see Half Dome. So, and that's something you can do, you know, if you're just visiting up there during the daytime, you could do that on your own. So a really cool thing happened, totally unexpected to me in my second year doing public programs at Lick Observatory. Was we were in the dome one night during an Evening with the Stars, a Friday night observing event, and as the sun starts going down, everybody just clears out of the dome, goes out and takes a look at, you know, really pretty sunsets, of course, which I don't blame them at all. But I actually looked up and saw the beam of sunlight going through, and I realized it was in June. It was near the summer solstice. I go, hey, that's kind of cool. And as the time went on and the sun got lower and lower, the image or the light coming through one window, and there's only 2 windows in the top area of the dome, they started to line up. I go, okay, that can't be, you know, that can't be by chance. And here's a shot of me in one window aiming and taking a picture out the other window 75 feet away. Okay, that is a really good alignment. This was 2 days before the summer solstice, so the declination of the moon hardly changes. And those windows are lined up, and it's got to be on purpose. I did some measurements a few months later. This is a quick diagram of to scale of the windows, and that alignment also misses the pier. The windows are offset to the north by about 4 feet, and that's, you know, a architect would draw them probably diametrically opposed on the building, and they're moved to the north, and that's got to be on purpose to line those windows up. Pretty weird. We don't know if that was really on purpose. We haven't found anybody that had documented it, and it's not in the blueprints of the dome at the time. I've got a lot of research to do on that to figure out who might have actually done that. All right. And so one of our last scopes is that we don't get to tour because it's a completely robotic telescope. I won't go into the details, but this is the Automatic Planet Finder telescope. We also call it the Rocky Planet Finder because it's designed to look for very small shifts in a star's position, radial velocity. As a planet would go around that star, it'll provide a red shift and blue shift to the star. And it's very sensitive instrument, fully robotic. Nobody really goes in there during the course of a night. It's all scripted and controlled remotely. And but every now and then, this was a volunteer orientation or appreciation night, excuse me, where the volunteers at Lick Observatory were led by Dr. Eleanor Gates there on the left through the APF, and it's a very tight fit in there. There's not a lot of room for people. Again, it's a robotic scope. It wasn't designed for people. And it's on an alta azimuth mount, not an equatorial, but it doesn't need that because it follows the stars of the computers just fine. It's a 2.4 meter telescope, 96 inches, which is the same size as the Hubble Space Telescope. So it is quite a piece of hardware. Beautiful telescope. The spectrograph, one of the most precise ever made. Here's a little plaque of the Levies that donated to help the spectroscope built. There's Costas Chloros, the Lick director, superintendent, and Ellie. This was during when they were re-illuminizing the APF mirror, taking it out. So another thing that PPTOs and a staff get a chance to do if we want to. This one's Andy Masika. Spends a lot of time up at the archives at Lick Observatory. He's been scanning plates. He's been recently scanning some of the original Lick refractor lunar plates. They're about 10 inches by 10 inches on glass plates. A lot of neat stuff in there. Is Halley's Comet Spectra plates from 1910, probably taken with the Crossley. I'm not sure. But that's pretty neat stuff. And these archives are being very slowly but methodically scanned. I'm actually hoping to spend a few days up there to help start scanning stuff as well during the course of the summer. It'd be a lot of fun. Some of all the books, log books of the observers. This one's from Holden, the first director up there from 1888. Some of his sketches kind of seems somewhat crude, but that's what they had back then. They weren't taking pictures through the telescopes quite that early yet. Some pretty amazing things. And lastly, I'm going to show one very quick thing that I discovered. Point Reyes Lighthouse. I was reading through the publications of Astronomical Society of the Pacific back a article from 1896, Perrine, who was actually discovered a couple moons of Jupiter at Lick Observatory. He actually said in this little article that he was able to see the Point Reyes Lighthouse from Lick about 88 miles away. Now that's closer, of course, than Half Dome, but it's down at closer to sea level. A lot of mist, a lot of fog, a lot of other things, and it's quite a difficult observation to make. And almost by accident, one night, a couple years ago, I was able to see the Point Reyes light. And here you can see just a diagram of where it is from Lick Observatory relative to Sutro Tower. And I got really, really, really lucky with an exposure on here showing the light from the Point Reyes light. It's still actually flashing at the same 5-second interval that it's been flashing since 1896. So pretty cool little bit of observing there. That was a lot of fun for me to do. And anyone can do it really if you get a good clear day up there. All right. So finally, just a little bit of quick recommended reading. There's some really good books done about Lick Observatory and the history, of course, up there. And most of these, if not all of them, are available in the Lick Observatory gift shop if you happen to go up there and take a look for them. The Eye on the Sky is excellent work about the first 100 years of Lick Observatory. Really neat articles and works in there. Day We Found the Universe. This one, The Generous Miser, about James Lick himself, primarily how he got his money and bequeathed it to the University of California for the building of James Lick Observatory. And we've got James Lick Monument. This is about after James Lick, primarily after James Lick passed away, how they built the observatory on the mountain and all the things they had to go through to make this one of the best first mountaintop observatory in the world. And if you want to know about E.E. Barnard, the man who discovered the 5th moon of Jupiter through the 36-inch refractor at Lick, it's a really good book on his life. After Lick Observatory, he went primarily to Yerkes Observatory in Chicago and did some great work there in Milky Way photography and other things. And then finally, Chasing the Stars, The Life of William Wallace Campbell. Campbell was a Lick director for over 30 years in the early 1900s, and really amazing work. I have to point out that the image here used on the front cover of the book is from world famous photographer and friend Lori Hatch, and she's the wife of former director Rem Stone at Lick Observatory. She's an amazing photographer. I can't say enough about her. She's this particular shot was taken near the Kate telescope on top of the water tank as the lightning bolts were coming closer and closer and closer to her, and Rem practically had to drag her down off the top of that water tank before something bad happened. So I want to thank a number of people that contributed to images in one way, either directly or indirectly to this talk. Russell Brown, Gary Varney, Dr. Eleanor Gates, we call her Ellie, of course. Neat lady. She takes some wonderful photos, and she provided a lot of the shots here tonight. Lori Hatch, that I just mentioned. Keith Wandry took a number of the shots of our tours in there. And then the Mary Shane Archives at UC Santa Cruz has a lot of the shots that the shots from the early 1800s and stuff are kept there at the Mary Shane Archives. And of course, the ham cam photos that you saw a few of. So that's about all I had at this point. I hope you guys enjoyed the talk. We can definitely open this up for some questions at this point. Let me get my microphone going here so we can hear you all. So if you would like to
Rick,
unmute.
Thank you.
Yeah.
Thank you very much for that talk. That was awesome. So what I asked folks to do is, if they've got questions, to enter them into the chat.
Oh, gotcha.
So
okay.
you can actually read the questions and work your way through them.
If we can do that, I think I'm ready there. Oh, wow. We got a lot of chats here. I might not be able to read all these, Gary. Let's see. No, thank you guys for doing that. No, that was great. That's worked.
Brian Day's got the first question there.
Oh, what happened to the Bowler and Chivens 24-inch? I have seen parts of it, not the whole thing. It was mostly the mount underneath in the Shane telescope in storage. So I believe, I don't know if the telescope itself is there. I'd have to probably get a hold of Ellie at some point and ask her, or go down there and try to find it myself, see what exactly happened. It's a nice telescope. It's really a shame, but it's too small really for them to want to put it up at Lick Observatory again. It's just not big enough to do the science that they would want. What is the F ratio of the Tachman telescope? It's the primary mirror is f5. I found that out. The final focus, I've been told from measurements I've seen, as I believe f17 on that. Let's see, from Jim Baumgart, is it true that the 120-inch mirror started life as a test flat for the 200-inch? Yes, it is true. It was when they were casting the 200-inch mirror for the Hale telescope. They brand new glass called Pyrex from Corning Glassworks in New York, and they didn't know a bunch about it to cast it in large pieces, and especially with a honeycomb pattern on the back, the stresses and things. So they cast, I believe they started with a 60-inch blank, and then they went to 120-inch, and then they had the 200-inch, and I believe one of the 200 inches it was a failure at first, if I'm not mistaken. I might be way off on that. But the 120-inch ended up at Caltech, and it just sat there for years and years and years. And C. Donald Shane, who the telescope's named after, back before World War I, actually, or World War II, actually, building that. So the 120-inch blank was gotten from Caltech. It would cost, also, I mentioned another number back there, $50,000, and that's cheap. They insured it immediately for about $2 million, and then they trekked it all the way to the top of the mountain. Now, it was just a blank. They did all the polishing, or rough grinding, and they did all the polishing. Took about 6 years of grinding that thing down in the basement in the floor of the Shane dome. And so the mirror was completed there, right there on site. Back then, that was a pretty amazing feat all by itself.
Rick, yep. Rick, can you hear me?
Yes.
I'm just going to say the first 200-inch mirror casting is at Corning Glassworks back in New York.
That's okay. That's what I thought.
I've actually seen it. It's on display in their museum.
Okay. Okay. So it didn't crack.
No. Well,
okay.
A couple of the cores, or one of the cores, the holding bolt broke loose, and the core part floated up to the surface.
But it was a successful cast. Okay. No, that's good.
Yeah, the cast itself was okay, but they couldn't use it.
So to get to your other part of the question, yeah, it was a really thin mirror with a honeycomb back, so they couldn't grind it to anything faster than an f5. The Sagitta, the depth of the mirror is about 1.5 inches at the middle to make it f5, and they couldn't go deeper than that. So it is a pretty long focal length telescope, actually, really. All right, so let's keep going. We got Jim Turman. Rick, do you facilitate the scientific research done at Lick? No, not really, not directly. As a public programs telescope operator, I basically point the telescope and talk about what we're looking at through the telescope. I have done a few things up there with the Talkman. I have done on my own several asteroid occultations up there in the last 5 years. But I don't really get directly involved with the science. There is a project I might be working on soon that's not defined yet, and I can't really even talk about it. That might be a lot of fun. So yeah, maybe a little bit, but it does take time, and I'm not a professional astronomer, and I probably never could be. But no, that's a good question. Thank you for asking that. Let's see, is the double astrograph being left in place during the Panseti work? Yes. When I first got up there in 2015, the double astrograph was literally on the chopping block, where they were even discussing taking it out of the building and either selling it or scrapping it. Be nice to have, 20-inch binoculars in your backyard. Hey, you got the right optics for that. But they've decided to leave that in place. They've repainted everything. The Panseti work, I don't know how long that's going to go, because it is a prototype, and whether they're going to keep that in there or they're just getting all their test data. I believe that's primarily, but they fully repainted the dome. It's in beautiful shape. And the telescope right now, it is not being used at all. I don't think no one makes 17-inch glass photographic plates anymore anyway. So pretty much useless for photography, at least without going digital, of course. All right. So the next question. Oh, Andy, one of our PPTOs that I showed a picture of up there. He said, excellent talk. You should give it to the volunteer orientation. Maybe. All right. From Oliver. Are excited sodium atoms still used in the adaptive optics work? Different spectral wavelengths now used? And no, it's primarily, so what Oliver's referring to is the Shane telescope is, even though it's relatively small in today's terms, when you talk about things like 10-meter telescopes, the Shane 3-meter or 120-inch telescope, it's been kept at the forefront of scientific use at Lick Observatory for a very key reason. It uses adaptive optics, which deconvolute our atmosphere and give very, very sharp images. The Shane could image almost down to the level that the Hubble Space Telescope can see in space, but on a much smaller field of view, not as big across the field. And when you're pointing at an object like an active galactic quasar, active galactic nuclei, or you need some real sharp detail, like this telescope has been used on Neptune and Pluto, or Uranus and Neptune, doing cloud studies recently. You use what's called the adaptive optics. But if you have an object that is not a point source, like a galaxy, you have to make a star. So what laser guide star is, it was that shot that I showed earlier where you see that orange ray coming out of the telescope. That's a 12-watt laser that shoots up into our atmosphere, and about 68 miles or so high above our atmosphere, in our atmosphere, is a sodium layer of atoms. Those sodium atoms come from micrometeorite influx over the course of days, weeks, whatever. So there's the sodium layer he's talking about. You can excite those atoms to fluoresce if you hit them with the right frequency laser. So the laser is being used as a sodium laser. It's tuned. It's basically the same color that the sodium street lights are around San Jose, and that special frequency allows those atoms to excite, and it makes the air glow like a neon tube. So you get a spot, 68 miles up, that's about 8 inches in diameter, and through the Shane that looks like a star. Now you use that star, that point, like a point source. Now that you know it's supposed to be a point, the adaptive optics do its magic. And I could get into details, but it'd take all night. There's a deformable mirror that actually takes the data from the detector, and it literally deconvolutes the wavefront, the contorted wavefront coming into the Shane, and it makes it almost perfect, just as if the telescope was out in space. Antonio, hey Antonio, how you doing? How often is the 40-inch nickel mirror redone? The nickel mirror is pretty much the same. All the telescopes that are used for science up there are pure aluminum. They're not overcoated. The overcoating causes problems, causes spectral spectral shift in the reflectivity of the aluminum. And so they use literally pure aluminum, which over time, it does have to be cleaned every now and then with soap, mild soap, other things. So it does, it does slowly wear down. Now, when you buy a amateur telescope nowadays, like a Celestron or Meade, the aluminum, it's either enhanced aluminum and it's usually overcoated. So those they'll last 25 years or more. The Lick telescope, the mirrors are all pure aluminum. It does etch down slowly. So about every 5 years. So I've seen the APF reilluminized once. I've seen the Shane reilluminized twice. They do the nickel scope. I haven't seen that one reilluminized myself personally, and even the Tachman telescope. This is sort of where, again, there's not really a budget to keep the Tachman operational, but they took the Tachman out and reilluminized it with other optics that they need on the mountain, like the secondary mirrors that are used at Lick. So it didn't cost them anything to do the Tachman. It was done along piggyback with other optics that are needed on the mountain. All right. So let's see. There used to be a spare. Okay, we went through the spare mirror for the 200-inch. Antonio, is there anyone residing at Lick anymore? Oh yeah, absolutely. So Lick Observatory staff, there's about, don't quote me on an exact number, but there's about 26 people. There were 2, and now I believe there's 3 staff astronomers. Dr. Eleanor Gates, Ellie is one of them. Dr. Paul Lanham is another. I think they just recently added one. I'm not really sure. So as far as the staff astronomers, there's 3. They have the superintendent up there, Costas Chloros, and his admin staff that's up there. There's a lot of facilities guys to keep all that equipment running. There's telescope technicians that keep that stuff running. There's computer people that keep that stuff running. There is 1 or 2 assigned like laser technicians that keep that sodium laser running, because it is an old sodium laser. It takes a lot of work to keep it up and running. So there's about 26 people up on the mountain still. So you see a lot of homes up there. They are, and there's a dorm area on the mountain. There are visiting astronomers always that come up. And the actual staff that stays on site, that stays on the mountains, about 26 right now. Okay. What happens to the old telescopes once they are no longer used, donated to museums? The answer to that's kind of no. As you saw, the Crossley, the double Astrograph, they're all at the moment in place. They weren't sent anywhere else. I'm not aware of any historic telescope that is not on the mountain. There was in the nickel telescope, the 40-inch that's in the north part of the main building there. There was initially an Alvin Clark 12-inch refractor. It was the first instrument on the mountain in 1881. King David Kalakaua of Hawaii, the Merry Monarch, actually was the first public person to look through that telescope before the transit of Venus years ago. Pretty interesting history. But in 1979, the nickel telescope was built from a donation of Anna Nickel, who was basically a seamstress in San Francisco that had $28,000 she wanted to donate, which sort of got the money seeded to start thinking about building a larger telescope. That certainly wasn't enough to build the Anna Nickel telescope, so they enlisted the help of machinists and UC students and a lot of people, where they donated and volunteered time to build the nickel telescope. And we actually call it the junkyard telescope because it's built out of steam pipes. It's built out of scrap metal, but it's a magnificent telescope. It's really, it's one of the most accurate driving telescopes that there is. And that was installed in 1979. So the 12-inch Alvin Clark refractor, beautiful telescope. It is in the optics area of UC Santa Cruz. I don't know exactly where that is or what building that is in, but there are plans, possibly, it all depends on money, of course. They would like to eventually put that back in the main building and move the 40-inch elsewhere if they can ever figure out a way to do that. Probably would be a long thing in coming, might take some donations, of course, to be able to do that, but they'd like to get the Lick main building back to the original 36, which is there, and the original 12-inch, because now that makes that building even more historic and could be a National Historic Monument, perhaps. So I don't know if that's an advantage or not, or a disadvantage to the mountain, but I don't know of any other scopes up there that were moved offhand. Okay, let's see here. Is Shiloh yeah, I remember Shiloh. associated with Lick. No, Shiloh died quite a long time ago. I don't know exactly when. He was one of the authors of the Eye on the Sky book that you saw or later in the presentation there. Shiloh was a neat guy. We met him a number of times. He had actually given a few talks to the Peninsula Astronomical Society, and he was kind of touted, he was a Lick historian. Now, whether he was a trained historian or an amateur historian like myself, he did a lot of research. He dug up a lot of neat things, wrote that book along with the others on the cover there, and really interesting guy. But for those interested in large refractors, Donald Osterbrock, Arthur Yerkes Observatory. Okay, yeah, I have not seen that one yet. But the same gentleman that wrote The Eye on the Sky with Shiloh, Donald Osterbrock, wrote Yerkes Observatory 1892 to 1950, located at Williams Bay, Wisconsin, outside of Chicago. Yeah, interesting. I have not read that book yet. That might be interesting. Have to grab that one. Was there ever, has there fire damage of the telescopes they're building up there? Yeah. So the big fire in August 2020 or 2020, it got very close to a lot of the domes up there. And fortunately, there was some not much damage. There was a outer shed that burned. There's some of the resident buildings were damaged, but not burnt completely to the ground, but bad enough where they can't live in a couple of them. The only thing that burned, which might have been, well, it was not really on purpose, but there was a Barnard home near the Crossley. It lived in by E. Barnard back in the 1890s, and it was used for a number of astronomers up there. It was very near what's called the Lick's Director House, which Ellie lives in right now. And it was falling apart. It was used for a little bit of storage, and it was basically slated to be demolished at one point, condemned. So when the fire swept through and came up the slope right toward the main building, right near Ellie's house in the Crossley reflector, the Barnard house did catch fire and it burnt to the ground. I actually have video of that, and Ellie does too. If you go on YouTube, and I didn't put this in any of the notes, but I'll just say this out verbally. If you go on YouTube and you type in my handle, my name, username, it's XB70man, XB70MAN, and just search on anything. I have a lot of rocket launch photos or videos. I've got a lot of Lick shots, time-lapse things that I've taken up there as a staff member. So of places that you normally can't get to, like this talk was all about. And I hope you find some of those really interesting. It's been a lot of fun being up there and being able to be on the mountain late at night and use the telescopes after hours in a couple of cases. By the way, just to clarify that, of the 6 years I've worked up there, I've only used the nickel telescope, the 40-inch, about 3 times till dawn. Now, this is all after the public programs and after the public leaves. So the eyepiece is still on the telescope, and they just allow us to use it until the sun comes up. So, speaking of William too, we almost killed him one night during a public evening tour. We were opening the dome of the 36-inch refractor, which uses big cables and motors and everything. And when the dome slits got about halfway open, we heard this big loud pop inside the dome. And I go, what was that? But the dome did keep moving. It kept cruising along, didn't think anything was really bad. And about a minute or two later, William comes walking in with this giant pulley in his hand and said it almost hit him out in the parking lot. So we were really lucky we didn't hurt William and
put a big dent in the ground.
Oh yeah, it was amazing. I actually asked, the thing was bent pretty badly, and I actually asked the Lick staff, I go, can I keep that so William could put it on his mantle? And they actually fixed it, and they were able to use it again. So they had to keep the original piece up there if they could, I guess. Pretty interesting. But to get back to my point on the 36-inch refractor, yeah, you have to have 2 people up there to use it. I have the ability to point the telescope on my own and up at the pier and go down to the eyepiece and get an object in the eyepiece. But you can imagine that'd be really dangerous. And if the telescope started moving, wrongly, or the clamp didn't clamp right, and the telescope started moving with that objective lens heading down to the floor, would be disaster, of course. So we do not use the 36-inch out without at least 2 people there, of course. I have used it to take photos, as you saw, but not usually with 2 people. You know, the other person wants to leave, head home. So, you know, I think we've used it till 2, 3 in the morning maybe, but never till dawn. But this is great. You guys have been great. I really appreciate being able to speak to you tonight. It's a lot of fun to work up there. You know, every now and then they do need other people, and they are always looking for volunteers up there. And the volunteers do get trained on the nickel telescope. They get trained on the eyepiece end of the 36-inch. The only thing that they only let us do is climb up the pier with a climbing gear for safety's sake. So they are always looking for volunteers. You'll see things occasionally, and if I get any heads up from Ellie or anyone about working up there, I'll certainly forward it along to the club. They need people. Laser spotting is one thing I didn't talk about. When that Shane telescope is shooting the laser up in the air, they need 2 people outside to make sure an aircraft won't fly into that beam. Now there is a radar system on the Shane, but that is a single thing and a single point failure that the FAA just won't allow. So we actually have human spotters on the east side and the west side of the dome that are up there looking from 10 o'clock at night till 5 in the morning, making sure planes won't fly through the beam. And they have a kill switch. If they see a plane getting close to the beam, they hit a big red switch and a shutter will go across the laser and shut it off. So they need people to do that. And I think it'd be interesting to do. I've never done it, to be honest, but it's because they have to train you properly. And so I can't just go in there and do it myself without some proper training, but it is a job. They actually pay you and everything to be up there doing it. So I'll pass those along if I ever hear anything else. All right, folks. So Gary, anything else, or club wise? I think we're business wise. We don't yet have a speaker set up for February. I'm always looking, of course, and there are a couple of things I have in the works. I'm hoping to still get a February speaker. I mean, this COVID looks like it's going to keep going on for a while. And, you know, we're getting up at Foothill into a room again, or even Los Altos Library like we were using back a couple of years ago. That is not likely to happen, at least, you know, for the foreseeable future. I'm actually thrilled that Lick is at least still pursuing trying to get the public programs done up at Lick. I'm sure it'll be at a reduced volume of people for safety's sake, and the public evening tours that we do when we walk around the mountain to the Shane and to the other telescopes around the mountain and use the 36-inch at night, that we keep that down to like 20 to 30 people. So it's not a lot, and that's pretty manageable up there as far as the COVID constraints and everything. So really enjoyed talking with you guys. I hope you learned a little bit, and I could have covered a ton more. I sent my presentation to Ellie, and she didn't know exactly how fast I talk about things or how fast I go through slides, but I had about double the number of slides, and I had to cut them in the last couple of hours because it's just way too much to talk about. I could probably do another talk on the stuff that I didn't show you tonight.
We're going to take you up on that. Well, thanks, Rick. I think, we could wrap it up here. If any more questions, please throw them in the chat or unmute your mic. But other than that, Rick, we'll let you close it out here.
Vote.
Yeah. Please vote, everyone.
Send in your ballot.
Our club business still has to go on. We still have to make decisions on our budget and our people and Oak Ridge and Foothill. So there's still actually a lot of business going on. It's been obviously pretty muted. We don't get to see everyone as much as we'd like up there on the mount, up there at Foothill and opening it up Friday nights to the public and everything. But I imagine that's coming around. I mean, if Disneyland's open, hey, we can open.
All right, Rick, I'll let you close it.
All right, we're all set, folks. Well, thanks for joining us. We'll hopefully see you next month, February. I'll send out meeting announcements early enough, and hopefully we'll see you then. Good night, everyone. Be safe.
Yeah, thank you.